I'm not a huge fan of a lot of slides when I'm working on videos and such, but since this is an introduction and a start, I think it's appropriate that we have a few slides. Well, first, what's a program? Well, it's a set of instructions that the computer can execute. And we have source code. That's what we sit there and type, what we write. We have executable code, and that is the machine instructions the computer can understand and execute. And we have to convert our source code to this executable machine code. Now, there are different programming languages, and we can do the same thing in most of them. Some are better than others. And here are just three examples of different languages. Now, some programs are we called compiled, and there we create executable code that's stored on disk, and we can run it as often as we want. We create it, we write the source code, we run it through a program called a compiler that converts and creates a file that's stored on disk that's your executable code. It's generally faster than other types, such as interpreted languages. We need to compile it for every operating system that we use. And some examples of compiled programs: C, C++, and Fortran. A compiled program, we write our source code, we run it through software that is a preprocessor, gets it ready, compiles it, converts it into the assembly language. There may be an intermediate step of an object code, and then stores the executable code on disk. And then we run that. So whenever you start Word or Excel or some program like that, you are running the executable code. Now, other languages are interpreted, and there the interpreter reads the source code, converts it to machine code, executes it, but it doesn't save it in a executable form. It does the conversion on the fly. It's generally slower than compiled programs, but today computers are so fast that's not usually a big problem. Since it's converted to machine code, as the program runs, an interpreter needs to be available for each platform it runs on. So if I'm on Windows, I take my source code to that Windows computer. I have an interpreter for it running on Windows, and it converts it and runs it. If I'm on a Mac, the same thing happens. So generally, it reads an instruction, it interprets it, creates it into the bytecode or machine code, and executes it. Source code to machine code, you've got, again, that source code. It converts it into really ones and zeros, shown here in the bottom in a hexadecimal form, but these are each of these are ones and zeros. In a sort of understandable form, this move AL would be maybe this first line of instructions. Python is an interpreted language. It was first released in 1991 by Guido van Rossum. It's object-oriented. They actually have a programming style and philosophy for it. Well, Guido was a big fan of Monty Python, so he named it after the comedy troupe Monty Python. Now, C++ was created in 1979 by Bjorn Stroup. Hope I'm pronouncing it close to right. It was based on the C language. Originally, they called it C with classes, and then they renamed it. And the first public release was in 1985. Now, Fortran is the old guy. It was first released in 1957. Currently, there's a 2023 standard and it continues updating and evolving. It is very good for scientific and engineering program. It is very fast for performance, deals with a lot of mathematical engineering problems, and it will run on very parallel processing, giving it advantages to, again, certain scientific programs. Well, there are a lot of other languages. There are hundreds. A few of these here I've listed: Rust, Go, Pascal, Java. So you could choose your favorite language and you just have to learn the specifics of that language.